Remember what we did? The idea is exactly the same. Well, maybe it doesn't look exactly the same, but like remember how we turned the second order ODE into a first order ODE? So we have a du squared u dt squared equal to f of u, for example. We are saying, okay, we can introduce a vector v, right? We can say v is equal to du dt and u. So now when I take the first order derivative of v, we get something like f of u, which can be written as f of v, right? And du dt, which is part of v, right? So now we can write down first order equation. We get a system. Now let's apply the same idea in our equation. Our equation, if we copy it, I don't know if I can copy this thing. Maybe I can. Let me try anyway. Okay. Good. Something got messed up. So t plus delta t is equal to, I think I have minus 3 over 2. Everything else is fine, right? When I have this thing, what I can write is I can write my vt. Let me use red on the left. I can write my vt plus delta t. I'm going to define it. I'm going to define it as a vector that contains u of t plus delta t. It also contains u at t and u t minus delta t. Okay? Which means that my v at t, the previous v, would include u at t, right? Every time it's shifted by delta t, right? U at t minus delta t and u t minus 2 delta t. Do you see the connection between these two methods? It's kind of in the first case, we have a second order ODE, right? We introduce another variable, we turn it into the first order ODE. In the second case, we have a algebraic relationship that uses not one term but 3 terms, right? So we are not writing u at t plus delta t as just a function of ut. It also includes 2 previous terms. Now by introducing this vector, we can write the v, the vector at t plus delta t, just as a function of vt, right? I don't have to include a v of t minus delta t or anything else. How do I do that? Can somebody tell me? How can I write my v of t plus delta t equal to something? Ideally, I want a matrix, right, times vt. How do I do that? What is going to be my matrix? Okay, 0, 1. Let's figure out the last row of the matrix. That's easiest, right? Last row of the matrix multiplied by this vector should give me the last last row of this, right? What do I need to multiply this to get this? 0 on 0, right? So 0, 1, 0. Oh, 0 is going to be multiplied by this. 1 is going to be multiplied by this to get the u of t minus delta t. That's what we want. So rest of them are 0, right? How about the middle row? 1, 0, 0, right? Okay. Good. So 1, 0, 0 multiplied by this, I get 1, so I get what I want. Others are 0, right? How about the top row? Yes, that's actually the coefficients in the equation. Because I want to get u of t plus delta t, right? and I have these three terms. I mean, these are just the terms in the equation. I have minus 3 over 2, and I get 3 and the minus half, right? I get a matrix. And am I stable or not? Just depends on, right? If I apply this matrix again and again, right? So I know my V of, let's say if t is equal to 0, then V of delta t is equal to this times V0, right? And V2 delta t is equal to this squared times V at 0. And V of n delta t is going to be this matrix to the nth power times V0, right? So if this matrix to the high power is going to be stable, then my scheme is stable. And what we observe is that very possibly the matrix to a high power is going to be something huge.